The attributes of the central office, the next generation, are to take from the big web scale companies and put those practices in the service provider network. In the central office, that means a transformation from an office which had purpose-built gear to a mini data center where you're running every network function and other applications on software on standard compute.
What we're seeing essentially is a need in the central office to reinvent and upgrade its architecture towards more server-based, more flexible architectures to take advantage of server-based economics. So the network simply cannot afford, literally petabytes of traffic going back from the devices, from the things that are going to get connected because of 5G, all the way thousands of miles, all the way back to a centralized data center.
And how the industry evolves towards cloudification, towards virtualization and containers, this is really there to support the 5G evolution. If we look at the 5G workloads, they really need to take into account the possibility to be virtualized, but even more containerized and cloud native. The flexibility in the use cases that is carried through and that the 5G is promising is built on top of a virtualized, containerized infrastructure, and it's built on top of managed an orchestration layer that will really carry through and place the workloads in the right place. So 5G is definitely built on top of the right cloud infrastructure, the cloud native applications, and the orchestration.
One of the things that we definitely hear from service providers is, as opposed to the way their COs used to be built with very proprietary, monolithically integrated solutions, they really want to go more on the open side. So open software, open hardware, still integrated and working very well together to provide the use cases, but not a single proprietary integrated stack.
With compute moving to different parts of the infrastructure, including next-generation central offices, operators quickly realized that x86 servers alone are not enough for NFV. CPUs are great for handling the control plane, but they're less optimal for actual packet processing. Offloading the data plane to FPGA SmartNICs provide ASIC-like deterministic performance, better security and low power consumption, while not compromising on data plane programmability. Moreover, it releases the CPU cores to handle the user applications they were designed for, thus further improving carriers' competitiveness. FPGA SmartNICs are well accepted today as an important ingredient in designing 5G UPF and next-generation central offices.
We are now sitting in a world which is full of edges. So you've got the telco central office, you've got public cloud providers like Google who have edges in their POPs, who have edges in their caches. You have IoT devices, you've got connected devices, you've got enterprises, retail stores. There are so many more edges, and the world is becoming one big distributed edge. And in this world, you're not just thinking about infrastructure, but you're now also thinking about services. How do you go deploy services in this world, which is multi-cloud, which has got a distributed edge?
Service providers really want to avoid vendor lock-in, and so they really want a broad ecosystem. They want open systems. And they want flexibility. Within the context of next generation central office, having equipment from a multitude of vendors across a broad ecosystem is critical, so that they're not tied into any one supplier to drive innovation. Having the disaggregation of software and hardware, and also the flexibility to attract services with open APIs. It really just gives them the advantage to bring in services in a much faster way.
Just as containers have begun to take over enterprise computing and all aspects of cloud computing, we expect telcos to begin adopting them both in their central offices, but particularly in the edge, where their more constrained environments are very well suited for the lighter weight container architectures.
With a cloud-native core, cloud-native infrastructure, we're able to really respond faster to the demands and to deploy capacity really where it's needed, at the time it's needed, for the services that are being required by the end users, by the enterprises, and so on. So it is really about complementing the 5G capabilities on the access side with a core network that is extremely flexible and extremely performant to deliver on the new services that are going to be launched.
We see a lot of change happening, not just at the technical level, but also at the cultural level. You know, organizations really are finding they need to deploy a whole new set of approaches to drive network transformation. So what we talk about is open platforms, open collaboration, and open innovation.